Jumbo. The title says how to complete an isotopes chart. Now I could scribble on the whiteboard or on a piece of paper, but some people claim my handwriting is not the neatest. So I've got my periodic table handy and I'm all set to fill this in. I check it out, I see isotope, that means I have to have the name and the atomic mass, which has a hyphen in between or a dash. The symbol is for an atom or an ion. I have to remember atomic number and protons are always the same, so I put an arrow pointing to both of them. So if I know the number here, I put it there. If I know the atomic number, I can put a number of protons. Then I have something called atomic mass, and I know that comes from the protons and neutrons. That's why it says equals protons plus neutrons. So I can use that information. And what students usually find the trickiest is figuring out the number of electrons or the charge, and you have to remember protons are positively charged, electrons are negatively charged. So I go to my periodic table for carbon, and there is carbon living at spot 6. Get out of the way, there he is. So I'm going to write down 6, and since I had a 6 for atomic number, I have 6 protons. Now this 14 is very convenient, so I have 14 there. So I put a 14 right here. Then I go and say, whoa, I need 6 plus something equals 14, or 14 minus 6 equals 8. And what students usually find the hardest is the electrons here. Well, right now I see there's no charge. That means it's an atom. And if I have 6 protons, I know an atom will have the same number of electrons. They cancel out. It is a tie ball game, 6 to 6. Here I see a 55 for the mass for manganese. So boom, right away I pop in a 55. Then I say, hey, manganese, where are you? And it's right here at spot 25. There's its atomic number. So I pop in a 25. And if I have a 25 there, I'll have a 25 there. They have to be the same. Now I go 55 minus 25. Rumor has it that is 30. And now it says 4 plus, and it means, what do I do with that? Well, it means in my basketball game between protons and electrons, because it's 4 pluses, that means the protons won by 4. So I go 25 minus 4, and that equals 21. So anytime positive ion, you end up with more protons, fewer electrons. If I had a negative ion, I'd end up with more electrons than protons. Now next one is shown a little differently, but it does give me some information. Right here I see a 15, and so I say, hey, well, this has to be a 15. So I'm going to make that nice and bold, 15. Then I go, oh, look at this, protons plus neutrons, 15 plus 16, and I get 31. Now I go to my periodic table, and I look at spot 15, and here's spot 15, the wacky world of phosphorus. So I'm going to write in, boom, phosphorus, and yeah, spelling counts, and 31. I don't put the 15 in, because I know if it's phosphorus, it's got to be 15. I've got to put the 31 in. And I have to put that in because it's the mass, the isotope, that can vary. Now, fried chicken, we got to put a P there. And I should have made it bold. There we are. And let's get that back over tabbed right. Okay, now I see I have 15 protons and 18 electrons. In other words, 18 minus 15 is 3. 3 extra minuses. So I have to put in 3 minus, and I'm done. So that gives you a pretty good sampling of how to deal with an isotopes chart. Yes, you should know it from Science 8. Yes, you should know it from Science 9. And here again, in previous notes and these notes, you've seen in Science 10. Make sure you find it easy, because it is easy.